Okay, so on worksheet 1.3a, problem number 14 is about Sarah rolling up and down a hill, right? So it's this, right? She gets to the hill, she's already moving, she rolls up the hill, isn't going fast enough, and eventually comes back down the hill. Good? All right, so my strong recommendation is when you're solving these, get a visual for what's happening and make a drawing. All right, when you make the drawing, I don't care about you drawing Sarah on a skateboard. What I want you to draw is the hill and the path that she follows as she goes up and down the hill. Something like this. Here's the hill. Here's Sarah. Boop, boop, boop. Hello. All right, and she's going to go up the hill and then come back down the hill.
It's a bottle.
Follow? Now, if you read through the problem, it tells you some information about her trip up and down the hill. For example, it tells you when she first reaches the hill, she's going at, is it 15 meters a second or am I thinking of a problem? It is 15, okay. So that represents the velocity right here when she first gets to the hill, right? Is everybody okay with that? Now, does the velocity stay 15? Is it 15 the entire time she's rolling?
No.
No, because it says she's not going fast enough and she slows down, stops, and comes back down the hill. So when I want to see you guys making these drawings. This is a common type of problem where a thing is moving in some direction, slows down, stops, and comes back down. There's the thing rolling up a hill problem. There's the Buzzy the bee gets thrown up into the air problem, which is really the same thing, right? Rolling up the hill, slows, stops, and comes back down, right? One of the homework problems had a frisbee or a bird or something that was flying into the wind. Whoa, right? Okay, so anytime you have one of these problems where it's moving in one direction, slowing down, and then coming back, I want to see this little drawing of it going and coming back. Okay, because you automatically know two other velocities. So, where else do I know the velocity?
At the top.
Good. At the top, for a split second, the velocity is 0, right? Because what's happening is it slows down, slows down, slows down, slows down, and stops. And then on the way down, what happens? Speeds up, speeds up, speeds up, speeds up, speeds up, speeds up, until by the time you get back to the bottom, now the velocity is negative 15. It returns back to its original velocity in the opposite direction, so negative 15 meters a second. Everybody good up to there? Yes.
So it's always the same velocity, I mean, like, except for the signs.
Correct.
Okay.
As long as the acceleration is constant, which it always will be in this class.
Okay.
Yeah. Good? All right. So, next order of business. The problem tells us that the hill causes her to accelerate at 3 meters per second squared. Now, I know I did this in first and second hour, I am not 100% sure that I did it in here. Have I talked in detail about what this means? Like, there were a whole bunch of problems in bold print on homework that said, explain what this acceleration tells us about the velocity. And I talked about the fact that it's 3 points on a test. Did we go through all that? Yes. So every second, the velocity, in this case, for this acceleration, because right now I've got it as positive, that would mean every second the velocity increases by 3 meters a second, right? Now, think back to worksheet 1.1 for a minute. I'm sure you don't remember the individual problems, but there were problems like this where it would say, like, Sally drives her car 800 miles west. And you would write down displacement equals negative 800, right? Even though I didn't give you the negative sign, you were able to infer, oh, it's going west, that means the displacement's negative. Okay? Similarly, when I give you an acceleration, you need to stop and go, I wonder if this is negative. All right? Based on what we've got here, does it make sense for the acceleration to be positive? No, because that would mean she's going up the hill faster and faster and faster and faster, but that's not what happens. The velocity's got to be decreasing for this to make sense, right? Conceptually, it's this. Remember, the rule that I taught you guys was anytime an object is speeding up, the acceleration points in the direction of motion. If it's slowing down, it points against the motion, right? So on the way up the hill, it's slowing down. So on the way up the hill, which way does my acceleration vector point? Downhill against the motion, right? On the way down the hill, it's speeding up. So now it points in the direction of motion. So my acceleration isn't 3, it's actually -3. So let me pause there for a minute. Does all of that make sense? Because I feel like once you get to this point, the rest of the problem is not that hard. Okay, but getting here is huge. So are there any questions before I go on? All right, so let's make a note here that we just found our acceleration. All right, now question A says something about how long is she rolling before she starts coming down or something like that, right? All right, so the other thing that you're going to hear me talk about a lot in the next chapter or so is this idea of time intervals. So all of these problems are about change. Either your position's changing or your velocity's changing or whatever. And anytime you have change, it takes time. So it's super important that you identify what the time interval is. So in this problem, it says, when does she start rolling down the hill? So it's saying, all right, she starts going up the hill. I want to know how long it takes before she gets to the point where she starts coming down, which is right here, right? So question A is asking me specifically about, oh, stupid highlighter. Question A is specifically asking me about this yellow time interval, right? And it wants to know how long it's going to take for her to get to that point where she starts going down. Good?
Good.
All right, so solution number 1, what I was hoping you guys would do on the worksheet last night, on worksheet 1.3a, was solve it conceptually. All right, so here's the deal. I know that when, at time 0, when the problem began, she had a velocity of 15 meters a second up the hill, right? And the question I want to figure out is how much time elapses, so I'm just going to kind of fill in a whole bunch of time here. How much time elapses before she gets to that point where she starts coming down the hill, right? So how do I fill in the chart? What happens to the velocity every second? It goes down by 3, right? So let's see, after 1 second, the velocity will be 12, then it's 9, then it's 6. Has she started going down the hill yet? No, because the velocities are still positive, so she's still going up the hill. All right, let's keep subtracting. 3, 0, -3. Now has she started going down the hill? How long did it take her to get to the point where she began going down the hill? 5 seconds, right? Because this is the point where she stops going up, and a teeny microsecond later, she'll start going down, right? Does that make sense, you guys? Okay, so there we go, 5 seconds. That's the answer to question A. Problems with that? All right, now, on tonight's homework, you're going to have problems just like this again. But I don't want you to solve them using the chart tonight. Tonight, I would like you to solve them using equations. I say tonight, this weekend, whatever, before I see you on Monday. I'd like you to solve these using equations. So what does that look like? Well, it's the same thing. All right, so let's do this. Let's take a second and identify the things we know about this yellow time interval here. So during that yellow time interval, what are the things we know? So first of all, do we know anything about the velocity during that yellow time interval? Yeah, so what does it start at?
15.
Okay, so my initial velocity is 15 meters a second. And the question wants to know how long will it take before I achieve a final velocity of 0, right? And what's the one other thing I know?
Acceleration.
The acceleration is -3, right? Follow? All right, so equations. Well, really, at this point, we've only got one equation. We know that acceleration is Vf minus Vi over t, right? And in this case, we're trying to solve for time. So you could, if you wanted to, just plug your numbers in and then solve for t. I'm going to do the algebra first and then plug the numbers in because I want to show you what A, because we're going to use this equation all the time. B, because I want to show you that it has meaning. So if I multiply by t and divide by a, you get this. Okay, so watch what happens. I plug in my numbers. VF is 0, minus VI is 15. So the top part of the fraction there is telling me how much the velocity has to decrease. It's got to go from 15 down to 0. Oops. Right? The velocity's got to get from 15 down to 0. It's got to decrease by 15, right? And I want to know how long that's going to take. Well, how much does it change every second?
3.
It goes down by 3. Right? So I'm taking the change of 15 and dividing it and counting how many chunks of 3 there are to find out it takes 5 seconds. So there's my time. Does that make sense, you guys? Yeah.
So the reasoning behind like doing the algebra first to get to like t equals is what again?
Oh, you don't have to.
Okay.
Yeah, you can put the numbers
Is there a
in.
way that's like better, I guess. Like, would you recommend a way?
I would. So here's why. We're going to use this equation. I'm sorry. We're going to use this. Well, we're going to use both equations, but specifically, we're going to use this equation all year. So my guess is if you start doing the algebra first, you'll just memorize this. And to me, that's way easier, just memorizing this equation instead of plugging in numbers and doing algebra every time. Do you know what I mean?
Yeah.
Whereas, like, it'll get to the point where, like, by chapter 3, I'll just throw this equation up on the board and expect you to know that it came from rearranging this one. Do you know what I mean?
Yeah, I know.
So, good? All right, now, did anybody do this? A ton of people in my first and second hour did this. So a lot of people are like, screw these stupid charts, Mr. Hacker. I'm sick of it. I'm going to do this mathematically. And plugged numbers into this equation and got a time of negative 5 seconds. Did that happen to anybody in here?
Not on that problem.
Not-
Other problems.
Okay. So this happened a lot in my other classes. And so what happened there was a lot of people just plugged in the numbers, but they didn't make the acceleration negative. And as a result, they got a negative time. When that happens, you made a mistake. Go find it. Don't just ignore the negative. Okay? You cannot have a negative time unless you have a time machine. And if you have a time machine, you don't know why you're sitting here right now.
True.
All right? Like,
That is yes.
go back and place a bet on some sports event that I don't know about. And then come back, like Biff in Back to the Future. But don't be a jerk about it. So when you get a negative time, that's a sign that you made a mistake somewhere. Go find it. Okay? Odds are you forgot a negative somewhere else, or maybe put an extra negative sign somewhere you shouldn't have. Cool? All right, questions on this? All right, one last thing, and then I'm going to shut up and I'll go around and answer individual questions. Because I do want you guys to have some time to work, and plus we're missing a bunch of people, so I don't want to spend too much time doing this. Because we'll probably have to talk about some of this again on Monday. All right, so thing 2, question B. So everything in question A was about this yellow time interval, right? Question B wants to know, what is Sarah's velocity after, is it 8 seconds or 9 seconds?
8 seconds.
8 seconds. So after 8 seconds, well, let's see. So we already figured out that it took 5 seconds to get here. So 8 seconds is going to be somewhere over here, right? Okay, and the question wants to know what's the velocity then. So check it out. There's 2 ways you can do it. Option 1 would be, oh, where did my chart go? Oh, I know what I did. I hit the wrong button. Come on, computer, stop being dumb. All right, so option 1 would be to use the chart and just keep going down to 8 seconds, right? So I'm already at negative 3. Minus 3 is negative 6. Minus 3 is negative 9. So the velocity ought to be negative 9, right? Okay. Option 2 is to write out what we know. So for this green time interval, it's always last hour that this highlighter doesn't work. It works great first and second hour, and then we go. All right. So what do we know about this green time interval? Well, let's see. I know the initial velocity, right? What do you got? Help me out, you guys. 15, right? I know that we're going to accelerate at -3 meters a second squared. The question wants to know what velocity will I reach at the end of 8 seconds, right? Cool? So, with that in mind, watch. Ouch. Getting old sucks. Just hurt my back turning. There we go. Okay, so check it out. So we know that acceleration is Vf minus Vi over t, right? And we're trying to find Vf. So let's rearrange this equation for Vf. Multiply by t, add Vi, and you get this. Vi equals Vf plus a, no, try again, Mr. Hecker, what are you doing? Solve for Vf. Multiply by t and add Vi. So Vf equals Vi plus a times t. Everybody okay that these two equations are the same thing? This is another one of those ones that we're going to use all the time. So, all right, so let's plug in our numbers. Check it out. What's my initial velocity, you guys?
15.
15. Oh, look, my initial velocity was 15. And then, what happens after that? Let's see. It accelerates. So the velocity decreases by 3 every second for 8 seconds. So this is telling me my velocity starts at 15 and then it decreases by 3 8 times. Look, the velocity begins at 15 and then it decreases by 3, 1, 2, 3, 4, 5, 6, 7, 8 times. All right, so this equation isn't just some random BS that some physics guy made up to make your life hard. It like actually means a thing, right? It's telling you my velocity starts at this, and then it changes a little bit every second. Follow? Does that make sense? Yeah, shoot.
Test, do we have to memorize the equation?
No, because you get that colorful equation sheet on the tests.
Oh, you always get it?
Yep, I'll give you a fresh, well, not a fresh one, but a laminated one. Cool. So you can write all over yours, but you get a clean one on test.
Gotcha.
Make sense, you guys? Questions with it? All right. So as you're doing the homework tonight or over the weekend, or I keep saying tonight, it's Friday, I'm probably not going to go home and do physics tonight, but as you're doing the homework over the weekend, I want you to be using this equation and manipulating it. Start by writing out your givens and then solve it. All right? Questions? Okay, I'm going to shut up. If I was to do a quick breakout session about number 15, about those positives and negatives, are there people who would